All right, hello guys. So for this video, I will be discussing proteins and NPNs, okay, or our non-protein nitrogen compounds. All right, so this will just be a short video. So rest assured that, of course, since I just gave it today, um, uh, what? Wait a minute. Okay, so I will be focusing more on the things that we were able to discuss last December 2021. Okay. But of course, I will still be including this in your quiz tomorrow. Yes, but yeah, I will be telling you what are the things that I will be focusing on, or what are the topics that I will be focusing on. Okay? Ayan. So to start off first, okay, so let us um recall what are the different general characteristics of our protein. So actually wala talagang laman itong slide na to. So this slide does not have anything. Okay. So anyway, yeah, I know, right? Wala yung mukha ko because basta ganun na yarn. Okay, so let's start. So take note that your proteins, yes, according to Bishop, so it comprises 50 to 70% of the cell's dry weight. Okay, so this is in reference to a cell's dry weight. So if you're going to look at it, okay, and of course, disregarding water, because we all know that water is also a predominant substance that is present in our cells. So kaya nga ang nakalagay dyan, so that's why I am emphasizing on dry weight. Okay, yes. So in this case, if we are going to consider a cell's dry weight, so your protein, so it comprises 50 to 70% of your cell. So that means out of all the biomolecules. So when we say biomolecules, we are pertaining to your carbohydrates, your lipids, your proteins, and your nucleic acids. So as you can see, yes, the predominant macromolecule or biomolecule that is present in our cells, we have your proteins. Okay, so please take note again, this is the predominant um, biomolecule that is present in our cells. Okay, yes. Yan. So as you can see, if you're going to look back at the different functions, or if you're going to look at the different functions of your proteins are actually diverse, right? When it comes to its type and when it comes to its function. So your enzymes are considered to be proteins, right? The different substances that are packaged and produced by your cells, they are proteins in general. The different structural um components of your cells are proteins. Okay, so that's why yeah, it is the predominant biomolecule that is present in our cells. Okay, because of its various functions, because of its various types. Okay, so aside from that, if you are going to look at the yes, if you're going to look at the unit by which we express our proteins, it is only the biomolecule that's expressed in grams per deciliter. Okay, why? Because remember that your proteins, particularly your plasma proteins, they are also important, di ba, components, or yeah, they are also important components of your plasma. Okay, yes, yes. That's why they are expressed as milligrams per deciliter, unlike for the other biomolecules that we determine or we assay in the laboratory. Like for example, we have your lipids, diba? Your lipids are expressed in milligrams per deciliter. Your carbohydrates also are expressed in milligrams per deciliter. Yes. So this would tell you that really proteins are the predominant biomolecules present, not just in the case of your cells, but also in the case of the extracellular matrix of blood, and that's your plasma. Okay? Yeah, so aside from that, take note that your proteins, this is the only biomolecule that contains nitrogen. Okay, so it is nitrogen containing. All right, so it is nitrogen containing. So it is actually the nitrogen that is present in your proteins. This is the one that will make your proteins unique from the other biomolecules that we have. Okay. Ayan po. All right. And then when it comes to the synthesis of your protein, so of course the predominant, diba? The predominant organ that is involved in its synthesis, we have your liver. Okay, yes. But of course, we have some proteins that are not produced by your liver. A good example would be our antibodies. So remember, our antibodies, they migrate to the gamma globulin region. That's why they are otherwise referred to as your gamma globulins or your immunoglobulins. Okay, so in the case of our antibodies, they are produced by your plasma cells. Right? Yeah. Okay, your plasma cells come from your B cells. Ayan, from your immunology. Okay, so yeah. So predominant organ, that's your liver. So one of the applications actually of your proteins or why we assay your proteins in the laboratory is for us to determine the synthetic function, di ba? The synthetic function of the liver. Okay, yes. So if there is something wrong with the concentration or the amount of proteins present in the plasma or the serum of our patients, then there is a likelihood that your liver might be affected. Okay, so your liver is not, okay, is not efficiently performing its synthetic function in particular. All right, so another important, yes, basic knowledge that we have to consider in the case of your protein. So take note that your proteins are amphoteric in nature. So when we say amphoteric, okay, so they might, the net charge of your proteins may be positive, okay. Net charge, wait a minute, okay. So the net charge of your protein, so it may be positive, okay, or negative. All right, yeah, so that is basically what the term amphoteric means. Okay, ayan. All right, so take note also that when it comes to its amphoteric nature, your proteins has or have an a positive charge. Okay, your proteins have a positive charge if the pH is acidic. Okay, and then if the pH is alkaline, your proteins will have a negative charge. All right. So those are the things, basic things that we have to remember, yes, and take note of when it comes to our proteins. Okay, so our concern mainly when it comes to our proteins, of course, we are concerned about the different fractions that are present in our plasma. Okay, and so let us discuss the different plasma protein fractions. All right, so take note. Yes, ang daming take note. All right, ang daming all right. Okay, wait lang po. Okay. Glit lang. Okay. Oh, hindi na all right. Okay. So the different protein fractions, so so they are based on the electrophoretic, okay, electrophoretic mobility of our proteins. Okay, yes. So remember that in general, when we talk about your electrophoresis, diba? When we talk about your electrophoresis, so this is a separation technique. Okay, so since there are many different kinds of plasma proteins that may be present in our sample, it is but natural for us to um, to separate them from one another so that we would be able to know what specific protein, diba? What specific protein is abnormal. Okay, so remember also that the different plasma protein fractions or the specific plasma proteins that we have, they are correlated. Diba? Their abnormal values may be correlated to specific diseases. Okay, yes. Of course, yeah, you have to separate them. Okay? So, again, another pa pala. Class, whenever you encounter the term electrophoresis, okay? So, always take note that your electrophoresis, it is primarily used for proteins. Okay? Substances that are protein in nature. A good example would be the one that we were already able to discuss. We have your lipoproteins. Lipoproteins, you are able to separate them via electrophoresis because they have a protein component, right? Yes, they have apolipoprotein in their structure. Okay, and then another the basis of our electrophoresis would be the net charge, diba? The net charge of your substance. Okay? And your proteins, the good thing about them is that they are amphoteric. So that's why we can separate them based on their net charge using electrophoresis. Okay, ayan. Okay, so pag nakita nyo yung electrophoresis, the biomolecule that we are able to apply this, in which rather, we are able to apply this particular method would be in the case of your proteins. Okay, ayan. All right. So again, your electrophoresis, it is based on the electric charge densities of your proteins. Okay. So when we talk about your electrophoresis, wait a minute. Ayan. So of course, electrophoresis would involve the use of your electrodes. And then plus, there are still a lot, maybe a lot, but hopefully not in your batch. So remember that when we talk about your electrodes, okay, yes, when we talk about your electrodes are charged. Diba? They are charged because they are supposed to attract a particular type of molecule. Okay, ayan. So, when we talk about your cathode, okay, sige, tanggalin ko nga muna ito. Kasi baka mamaya ako ang malito. Alright, so first, when we talk about your cathode, okay, cathode, what is your cathode? Your cathode has a negative charge. Okay, your cathode, I repeat, this is the electrode with a negative charge. Okay, so the reason why it is referred to as a cathode is because of the fact that your cathode being negatively charged will attract, diba? Will attract your cations. Okay? Your cations, class, these are positively charged. Okay? Tama ba? They are positively charged. So please, do not misunderstand. Kasi sometimes students would base the charge of the electrode on the name. Like for example, for cathode. Okay? Siyempre, sometimes ang iisipin or you would think that a cathode, okay, has a positive charge. But no, 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 no. The name of your electrodes, they are not based on their charges. They are based on the type, okay, of substance that it attracts. Tama? Ayan. So, cathode attracts cations, positively charged substances. Okay? Therefore, cathode should be negatively charged. Tama? Because remember that opposites attract. So that's our rule. Diba? That's our rule here. So opposites attract. Alright? Yeah. So when we talk about your anode, of course, the other, yes, the other electrode is your anode. So your anode class, this is, or this has a positive charge. So this is the electrode that is positively charged. The reason why we refer to it as an anode is because of the fact that it is the one that is capable of attracting your anions. What are our anions? Our anions are negatively charged. Okay. All right. All right. Okay. So when it comes to our electrophoresis, remember that your cathode, okay, dito na lang. Your cathode is the point of origin. So it is where we apply, diba? It is where we apply your serum. Okay, it is where we apply your serum. And then of course, your proteins being, di ba? Being amphoteric, so they will migrate to your, ano ba yan? Sorry, hindi pwedeng mag-ruler. I cannot, ganyan talaga. Okay. So it will migrate to your anode. Okay, so from your cathode, which is the point of application, and provided that your proteins, diba, will have a negative charge in your electrophoresis, um, they will migrate towards the anode. Okay, yes. Mom, yes. Why towards the anode? Okay, take note again that when we talk about electrophoresis, diba, this is carried out using an alkaline buffer. Okay, so specifically, the pH that is utilized for your electrophoresis is 8.6. Okay, so we go back. We go back to what I discussed when it comes to the general characteristics of your proteins. Remember, at an alkaline pH, your proteins are negatively charged. Yes, may pag ganun. Okay, they are negatively charged. And so, they will be attracted to the anode. Okay, they will be attracted towards the anode, and depending upon the net negative charge that each plasma protein carries, so this will now determine how far can your plasma protein go towards the anode. Okay, so let me just put it here. Ayan. So it migrates towards the anode. So simply put, it's like the anode, that's the finish line. Diba? That's the finish line in your electrophoresis. Okay? All right. So after electrophoresis, okay, so after electrophoresis, there would be 5 bands. Yes, there will be 5 bands that will be formed. Okay, what are the 5 bands? So of course, we start off with your cathode. Tama? So from your cathode towards your anode. Okay. So from your cathode towards your anode, the 5 bands that will be formed, of course, the most anodal, diba? The most anodal would be your albumin. Okay, yes, your albumin. Pero mahihirapan kasi akong magsulat. So that's why we start off with the most cathodal. Okay. So the most cathodal is your gamma, or R rather, your gamma globulins. So that means they migrate the least towards your anode. Yes, and if they migrate the least towards your anode, they are considered to be the slowest plasma protein fraction. All right, yes. The next one would be our beta globulins. Okay, and then we have your alpha 2 globulins. Okay, and ay sorry, alpha 2 tas alpha 1 ang sinulat. Alpha 2 globulins, and then we also have our alpha 1. Ako hindi kasha class. Alpha 1 globulins, okay? And then we have our albumin. All right, we have our albumin. So these are the 5. Yes, these are. Can I just remove globulins here? So we all know that it has globulin. Okay, ayan. All right. Yes. So these are the 5 bands that are produced in the electrophoresis of our plasma proteins. Okay? So there are instances when your pre-albumin, yes, becomes detectable on your electrophoresis. All right? So when we say pre-albumin, it comes before your albumin. Okay, so that means, yes, if we are going to consider pre-albumin, the most anodal is pre-albumin. All right. However, it is not part of the 5 bands. Okay, it is not part of the 5 bands. All right. So that's why, yes, you have to be careful na lang when it comes to the question that is given in your quiz or in your exam. Okay, yes. So of course, you have to be careful. Okay, so let us consider the different bands, the 5 bands. So if albumin migrates towards the anode the most, we consider albumin to be, okay, so we consider albumin to be, yes, it is referred to as the most anodal. Yes, it is referred to as the most anodal. It is referred to as the fastest. Okay, most anodal and the fastest. Okay, so why? Because it migrated the highest distance towards your anode. Okay, ayan. So of course, take note that your pre-albumin is more anodal than your albumin and it is faster as compared to your albumin. So that's why, yes, I mentioned, be careful in your quiz or exam. Do not just understand the question, but understand also the choices that are given. Okay, so yan. All right. Okay, so let's proceed. So later on, when we go to your SPE or your serum protein electrophoresis, so we will still be discussing particularly the different steps in electrophoresis. Okay, so let's discuss each of the 5 bands. So first, we have your albumin. Okay, so your albumin, so take note that this is the predominant, right? This is the predominant plasma protein in the circulation. And aside from that, take note also that it is synthesized by the liver. So the function of your albumin is to transport different substances, particularly our organic substances, such as your bilirubin, your steroids, and your fatty acids. Okay, so another important function of your albumin is that it is the one that is responsible, or it is a major contributor to the oncotic pressure. Okay, so when we say oncotic pressure, so this is the same as your colloidal osmotic pressure. Okay, yan. Yes, so it is a major contributor to colloidal osmotic pressure. So another take note also that your albumin, so it is an important plasma protein in maintaining water balance inside the body. Okay, so yes, it is important in maintaining um, maintaining proper water balance inside the body. Okay, all right. When it comes to anong pangalan nito? When it comes to its clinical significance, so albumin is an important protein that we can assay and correlate with the synthetic ability of your liver. Okay, yes. Being the predominant protein kasi, if there is something wrong with your liver, of course, yung distinguishable or yung distinct, di ba? The distinct fraction that will be affected would be your albumin. Okay, yes. So it is low. Yes, it is low or decreased in disorders affecting your liver. Okay, so aside from that, ano pa ba ang mai-share ko? Aside from that, your albumin class, lagi itong tinatanong sa board exam, it is increased. Okay, it is increased in the case of your dehydration. Okay, it is increased in the case of your dehydration. Okay, ayan. And then another pa pala, so your albumin, this is considered to be a negative acute phase reactant. Okay, so it is considered to be a negative, a negative acute phase reactant. So when we say negative acute phase reactant, um, its level is decreased in the case of inflammation. So remember, di ba, when we talk about your acute phase reactants, so these are substances. Yes, these are substances that are really so these are substances that are released by the body in response to your inflammation. Okay, so we actually have what we call positive acute phase reactants and then negative acute phase reactants. Okay, so one of the negative acute phase reactants that we have is your albumin. Okay, all right. Okay, so let's proceed. All right. So now let's move on to another plasma protein. So we have your pre-albumin. Okay, so take note that your pre-albumin, so this is otherwise referred to as your transthyretin. Okay, so another name of your pre-albumin is transthyretin. Okay, yes, transthyretin. Okay, so in serum or in plasma, yes, in serum or in plasma, it is not it does not form a distinct band. Okay, it's not form a distinct band in our serum protein electrophoresis unless it is increased. Okay, unless it is increased. Okay, so take note that when it comes to the predominance of your pre-albumin, it is more predominant in your CSF. Diba? It is more predominant in your CSF. So take note that your pre-albumin, this is the second most predominant, okay, in the case of your CSF, but not so much in your serum or plasma. So that's why normally wala siyang band. So it's not form a band in your electrophoresis. Okay? So when it comes to its ano pangalan nito? When it comes to its clinical significance, so take note that your pre-albumin, so this is considered to be an indicator, okay? An indicator of malnutrition. So actually, may I just share with you that, again, we have to be careful when it comes to answering questions about malnutrition. Okay, why? Because if it's malnutrition, if for example, the question says they're malnutrition in general, okay, in general, okay, malnutrition in general, or there was no specific type of malnutrition that was involved, then the correct answer is, of course, we have your prealbumin. Okay, however, take note that our references mention that your albumin, this is, okay, this is also associated with, sorry, this is also associated with protein calorie malnutrition. Okay, so again, you have to be careful. So is it a protein calorie malnutrition? Then of course, the correct answer would be your albumin. Or is it malnutrition in general? So if that would be the case, the correct answer would be your prealbumin. Okay, ayan. So when it comes to its function, so it is also capable of transporting important substances inside the body, such as your thyroid hormones and your retinol. Okay, so that's why it is otherwise referred to as your retinol binding protein. So when we say retinol, okay, what vitamin is your retinol? Retinol is your vitamin A. Okay, ayan. So when it comes to your vitamins, they would usually make use of the other names of your vitamins. So that's why you have to be familiar also with the other names of your sorry, vitamins. Okay, so retinol, that's your vitamin, right? So now let's move on to another group or another fraction that is seen in your electrophoresis. So we have your alpha 1 globulins. Okay. So in the board exam, so they would usually just ask where a particular plasma protein migrates. Okay, ayan. So like for example, alpha-fetoprotein migrates towards ganon. So you have to indicate in what region of your serum electrophoresis does your alpha-fetoprotein migrate to. Okay, so in this case, it's in your alpha-1 region. Okay, it is an alpha-1 globulin. So based on the recall questions that I have, so that is usually, yes, the one that they asked in the board exam, the migration patterns of the different plasma proteins. Okay. And so it is important for us to know what are the different specific plasma proteins that migrate towards uh, the different regions of your serum electrophoresis. Okay, so alpha 1 region, so we have your alpha 1 antitrypsin, alpha-1 acid glycoprotein. We have your alpha-1 anti-chymotrypsin, alpha fetoprotein, your GC globulin, inter-alpha trypsin inhibitor, and then we have your thyroxine binding globulin, and your HDL. Okay, yes. So out of the different alpha-1 globulins, so they have already asked, actually paulit-ulit to, since 2018. Yeah, since 2018, they asked about your alpha-1 acid glycoprotein. So the other name of your alpha-1 acid glycoprotein is orosmucoid. Okay, orosmucoid. So do not forget, other name of your alpha-1 acid glycoprotein is your orosmucoid. And then aside from that, yes, they also asked about your AFP, yes, and the significance of the presence of your AFP in your amniotic fluid. So remember that AFP, the clinical significance of this, in the case of your amniotic fluid, yes, in the case of your amniotic fluid, it is correlated with spina bifida. Okay, so it is correlated with your spina bifida. All right, so those are the different alpha-1 globulins. Okay, so now let's move on to our alpha-2 globulins. Okay, so dito medyo sorry, dito medyo they asked about the clinical significance of our alpha 2 globulins. Okay, so do not forget class that one of the alpha 2 globulins that we have is your alpha 2 macroglobulin. Okay, and take note, macro. Okay, so that means it has a big size. All right. So later we will still be encountering your alpha 2 macroglobulin when we talk about the different abnormal patterns in your electrophoresis. Okay, so we have alpha 2 macroglobulin. What else? We also have your ceruloplasmin. Yes, so remember that your ceruloplasmin, um, it is capable of binding copper. Yes. And in the case of copper deficiency, yan usually yung tinatanong nila, okay, in relation to copper. Yes, yes, in relation to copper. So we have in the case of your copper deficiency, yes, in the case of your copper deficiency, one manifestation that is seen in our patient is a term or is the term menkes kinky hair. Okay, so remember this manifestation is associated with copper deficiency. Okay, so what else? We also have your Kaeser-Fleischer rings. Okay, Kaeser-Fleischer rings on the other hand, so this is seen naman in your Wilson's disease. Okay, this is a manifestation that is seen in your Wilson's disease. So we have Kaeser-Fleischer or Fleischer, whatever. Sorry. Kaeser, Fleischer, or Fleischer. It's all Fleischer. Okay, Fleischer rings. Okay, so your Kaeser Fleischer rings. So this involves deposition of copper in the cornea. Okay, so this involves deposition of copper in the cornea. Okay, so next we have your haptoglobin. All right. So when we say haptoglobin, so take note that this is regarded as our hemoglobin carrier. Diba? So this is the hemoglobin carrier. And when it comes to its clinical significance in yeah, practice, so it is associated with hemolytic anemia, particularly in hemolytic anemia, your haptoglobin will have decreased value. Okay, so it will have a decreased value. Okay, all right. All right, so now let us move on to another fraction. So we have our beta globulin. Okay, so our beta globulin would include the following. So we have your LDL, your VLDL, your transferrin, your hemopexin, your beta 2 macroglobulin, your complement, and your C-reactive protein. When it comes to the different beta globulins, again, aside from their electrophoretic mobility, so you should also be familiar with their specific functions inside the body. Okay, so yeah. So your your transferrin, so this is the one that carries iron. Yes. So aside from its function, another na tinatanong sa board exam is what form of iron is carried by your transferrin. So kaya nga siya ferrin, di ba? Ferric. Okay, so Fe3 plus or plus 3, right? So it is the ferric form of iron that is carried by your transferrin. Okay, by your transferrin. Okay, so this is the reason why, di ba? Yeah, I remember this from our lecture in Himatu because Ma'am Earl was my teacher, was my instructor back then. And then he asked, he talaga, yeah, gusto niya naman ng he. Okay, so he asked me to explain, yes, explain the the handling of iron inside the body. Yeah, that's why. So remember, di ba, in the intestines, yes, there is a need for us to convert ferrous, right? Ferrous iron to ferric iron because ferrous iron cannot be carried via the circulation, right? Because your transferrin class, it is only capable of carrying ferric, the ferric form. Okay, and then of course your transferrin, so it will transport your iron in its ferric form in the bone marrow. Okay, why bone marrow? Because that is the site for your RBC production. So the problem is, in the case of your RBC production, what state or what kind of iron do you need? You need the ferrous form. Tama. Yeah, you need the ferrous form. So that's why you again have to convert it to the ferrous form. Okay, so anyway, yeah, I just remember it. All right, so we move on to another beta globulin that they have asked already in the board exam. So we have your hemopexin. Okay, so take note that your hemopexin, so this is also useful in the case of your hemolytic anemia. Okay, so in your hemolytic anemia, your hemopexin is also decreased. Okay, it is also decreased. All right. So yes, those are the different beta globulins or plasma proteins that migrate to the beta region of your serum electrophoresis. All right, so now let's move on to the last one. We have your gamma globulins. Your gamma globulins, yes, um, particularly they are, or this particular region comprises your immunoglobulins, or it is where your immunoglobulins migrate to. So, of course, we have to be familiar. What are the different immunoglobulins that we have? So we have your IgA, IgG, IgM, IgE, and your IgD. Okay, ayan. So, according to Henry, yes, according to Henry, kasi if you're going to compare the discussion of Henry and Bishop when it comes to the phoretic mobility of your plasma proteins, ang CRP, yes, ang CRP, according to Bishop, if I'm not mistaken, yeah, according to Bishop, CRP migrates to the beta globulin region. Okay, and however, according to Henry, C-reactive protein migrates to the gamma region. Yeah. Ma'am, what are we going to answer in the board exam? For me, I will choose Henry. Yes, for me, I will choose Henry. Or, actually, it depends na lang on the given choices. Diba? It would depend on the given choices na lang. Okay, so yan. So again, yes, you have to understand not just the question, but also the choices. All right, so another fibrinogen. Okay, so again, according to Henry, fibrinogen migrates between beta and gamma. Okay, yes, migrates between beta and gamma. We have our fibrinogen. All right. Okay, so actually in the board exam, um, yeah, parang hindi yata nawawala. I'm not sure in the recently concluded board exam, but they would usually ask about the abnormal electrophoretic patterns. Okay, and of course, they will not give you a graph. Okay, and so you should be able to understand your abnormal electrophoretic patterns. Okay, so as early as now, unless you want to make habol, but you cannot make habol naman to the March board exam because you will still be having your compre, diba? You still have your duty and your compre. So probably you will take the board exam by August. So as early as now, this is one of the topics that I want you to, yeah, I want you to master talaga. Yes, I want you to master in clinical chemistry. Okay, so we have the different abnormal electrophoretic. Okay. But of course, may intro pa ako, di ba? Before we go to the abnormal electrophoretic patterns, let us, because they asked this, steps in your electrophoresis. Okay, what are the different steps now involved in electrophoresis? Okay, so when you go to the laboratory and you want your you want yeah you want to you want to ano ba yan, nawawala ko class, you want to have electrophoresis, yes, you want to have serum protein electrophoresis, um ibibigay ba nila agad sa iyo yan? Okay, of course the answer is no. Okay, So remember that when it comes to clinical application of your serum protein electrophoresis, we start off with an abnormal protein concentration. Okay, so in the presence of an abnormal total protein or abnormal albumin concentrations, all right, so this is the only time that we can perform your SPE. What does SPE mean? Serum protein. Sige, lagay natin. Okay, so we have serum protein electrophoresis or phoresis. Okay, ayan. So why is there a need for us to perform your SPE or your serum protein electrophoresis? Remember that. Yes, remember that. When you perform total protein or when you perform albumin, diba? There would still be a need for us to determine. So like for example, in the case of your abnormal total protein, there is a need for us to determine, okay, to determine um, what fraction is involved in that particular abnormal total protein concentration or total protein results. Okay, so what fraction contributed to that abnormality in the concentration of your total protein? Okay, so that's why we have to perform serum protein electrophoresis in order for us to narrow down what particular fraction is involved. Okay, ayan. So in the case naman of an abnormal albumin, so there are conditions in which an abnormal albumin, um, is seen together with an abnormality in the other fractions. Okay, ayan. So like for example, for this particular graph, so as you can see, di ba? Wait. All right. So like for example, for this particular graph, so as you can see, the albumin, di ba? The albumin is decreased. Okay? So can we already use this as an evidence for the presence of a certain abnormality? Okay? Probably yes. However, of course, it would be good to also look at the other fractions, diba? So that the doctor would be able to correlate it. Okay? Is it just your albumin that is affected? And so the other fractions are also affected, right? And of course, together with your albumin, yes, we correlate our values also of, or we correlate the values also of the other, yes, the other fractions of your proteins. Okay, so ganun siya. Alright? Okay. Ayan. So, saan ko na ilalagay? Wala na akong paglalagyan. So anyway, class, can I just use, yeah, of course, you cannot react, but I will just use this. Okay, ayan. All right. So kasi if I'm not going to use this, it will be very hard for us. So steps in your electrophoresis or serum protein electrophoresis. So first is, of course, we have to separate. Diba? The first step is separation of your plasma fractions. Okay, so again, what's the basis for the separation of your proteins? So in the case of our proteins, our basis would be ang kanilang net negative charge. So that's our basis. Okay, why? Why net negative? Because remember that the pH that is utilized for your SPE is 8.6. Okay, in which your proteins will have a net negative charge. Okay, so if they have a net negative charge, so take note that your proteins will migrate, di ba? The migration pattern is that your proteins will migrate toward the anode. Okay, toward the anode. Okay, so what is our anode again? Our anode is the positively charged. Okay, it is the positively charged electrode and it attracts anions. So in this case, we can consider, diba? We can consider our proteins as anions because they are negatively charged. So just to review, we have 5 bands that are produced, diba, after separation. What are the 5 bands again? Yes, starting off with the most anodal or the fastest of our plasma protein fractions. We have your albumin, followed by your alpha 1, alpha 2, beta, and then of course gamma. That is the slowest or the most cathodal. Okay? So after separating your yes, after separating your plasma protein fractions, the next part or the next thing that you have to do is to fix, okay, your proteins in order to ensure that after separation they will they will stay in the area to which they migrated to. Okay, so you have to fix your protein fractions. And when it comes to your fixation, okay, so this involves immobilization, diba? It involves immobilization of your protein fractions via the process of denaturation or precipitation. Okay, good thing in the case of our proteins, diba, they have the ability to be denatured. They can undergo the process of denaturation. Okay, so when we fix our plasma protein fraction, so of course there is a need for us to make use of a denaturing, diba, denaturing reagent. And in the case of our SPE, it is usually an acid. Okay, so in the laboratory, the most commonly used acid for the fixation or the immobilization of our plasma protein fractions is your acetic acid. Okay, yes. Okay, so your acetic acid will precipitate and your acetic acid rather will denature and precipitate your proteins at which, okay, or where they have migrated to. All right. So say for example, we have uh, our alpha 1 globulins. Okay, so your alpha 1 globulins, they will stay there because they have been immobilized already. Ayan. And so if you immobilize your plasma protein fractions, then we would be able to determine the concentration of our plasma proteins. Okay? And so, ang next na step natin is, ang next na steps pala natin would allow us to determine the concentrations of the different plasma protein fractions. Right? Of course, diba? The first thing is for you to be able to visualize. Right? Yes. So how can you visualize something? You stain it. All right. So what are the different staining solutions or stains that we use in the case of our plasma protein fraction? So we have our Ponchu S, okay, we have our Amido Black, okay, and then the last one we have our Kumasi. Kumasi. Yes, Kumasi Blue. All right. So these are the different stains that we use. All right. So the next thing that you can do, you can actually proceed to what we refer to as your qualitative identification. Okay, so you can already proceed to the qualitative identification of your abnormal proteins. So when we say qualitative identification, of course, at the end of your qualitative identification, you will not have a concentration. Diba? Why? Because it's just qualitative. So you will just be comparing the bands that were formed. Yeah, so this would involve visual inspection of the different bands that are formed. So in particular, what are we visually inspecting? We are inspecting the width of the bands. Okay, the width of the band. All right, so the width of your bands. So this will also depend upon the homogeneity of the fractions. All right, yeah, so you can already provide a qualitative assessment of the different protein fractions, okay, by visual inspection. However, of course, if you want to really come up with concentrations of the different fractions, you can perform quantitation. Okay, so you can perform quantitation. Okay, so remember that the quantitation that is performed after staining is via densitometric. Densitometric scanners. Okay, yes. So via densitometric scanners. Yes, they would usually ask this in the board exam. Quantitation of plasma proteins, or which of the following is used to quantitate plasma proteins. Okay, in serum protein electrophoresis. So the correct answer is densitometry. Right. So after quantitation via your densitometric scanners, what you will actually have is a a relative value for the different fractions. So when we say relative value, again, what's the unit? Okay, very good. So we have your percent. Diba? Relative quantity ang makukuha mo dyan. And so just like when we perform our differential count in HEMA, diba, what you have or what the machine will give you will just be relative counts. Okay, so in order for us to know the absolute value or the absolute concentration of the different fractions, you have to multiply, di ba? Multiply the percent or the relative quantity of the different fractions by your total protein. Okay, multiply by your total protein concentration. So after multiplying it with your total protein concentration, you would now be able to get the absolute value for the different fractions of your proteins. Okay, so those are the different steps which are involved in your serum protein electrophoresis. Okay. All right. So if I am going to proceed, you will not be able to see this anymore. So anyway, you can naman rewind. Tama ba ako? Yeah, rewind. Okay, so that you would be able to copy the different steps. Oh, like this. Oh, di ba? You cannot see it anymore. So kindly rewind na lang if you were not able to take down. Okay, so these are the different abnormal electrophoretic patterns. Okay, so the first one, of course, sorry. The first one is this first one. So this shows your nephrotic syndrome. Ayan lang. This one shows your nephrotic syndrome. Okay, what is nephrotic syndrome again? Nephrotic syndrome, di ba? You discussed this in your clinical microscopy, in which there is an increase in the excretion of your low molecular weight proteins. Okay, yeah, so you are going to lose your low molecular weight proteins via your urine. All right, so if you're going to look at the abnormalities that are involved. Okay? Um, Significant abnormalities that are quite distinct in the electrophoretic pattern of your nephrotic syndrome is that your albumin is very low. Okay, yes, because it's a very small, di ba? It's a very small protein as compared to the other proteins that we have in our plasma. And so you would lose, di ba? Predominantly your albumin in your urine. So that's why, okay, that's why it is significantly decreased in your nephrotic syndrome. Okay, however, it is also important to note that as you can see, the other fractions are also decreased. Diba? Yan. So we have your, this is your albumin, this is your alpha 1, alpha 2, beta, and then gamma. Okay, so your alpha 1 region is also decreased. So meaning the different, diba? The different low molecular weight proteins that migrate to your alpha 1 region, so you also lose them. Same is true with the different low molecular weight proteins that migrate to your beta and your gamma regions. Okay, so yan. However, another important thing that is quite distinct in the electrophoretic pattern of your nephrotic syndrome is there is an increase, okay, in your alpha 2 macroglobulin. All right. Why is there a significant increase in your alpha 2 macroglobulin? This is because it is a macroglobulin. Okay, so that means it is one of the proteins that is retained in the circulation. You do not lose it in your nephrotic syndrome. Aside from that, your alpha 2 macroglobulin, it is a predominant, okay, plasma protein in the alpha 2 region. Alright, ayan. So that's why there would really be an increase or an elevation of your alpha-2 macroglobulin in, di ba, in reference to the other plasma proteins which you are constantly losing in your nephrotic syndrome. So since macro siya, okay. So let me just, in here, wait lang. Okay. The significant or the distinct patterns would be your albumin will be significantly decreased, and then your alpha 2 region, you can see there it is increased, diba? So this is due to the increase of your alpha 2 macroglobulin in reference to the other plasma proteins which you are losing, okay, in the case of your nephrotic syndrome. Okay, so alpha 2 macroglobulin is significantly increased in the case of your nephrotic syndrome. All right, so yeah. So another, we have this one naman, this is the electrophoretic pattern that is associated with your cirrhosis. Cirrhosis. Okay, so this is um the abnormal or the electrophoretic pattern that is associated with your cirrhosis. Okay? So in the case of your cirrhosis, liver cirrhosis, all right? So this is, there are two predominant patterns that you have to be able to take note of. So number one, there is a decrease, but not as significant as that in your nephrotic syndrome. There is a decrease in your albumin, and it seems like, no, hindi it seems like, there is a, anong pangalan nito? Yung nag-merge, di ba? Yeah. There is a merging, okay, of your beta and gamma region. All right. So this particular merging, wait, before we go to that. So albumin, so this will likewise be decreased, but not as decreased as that in your nephrotic syndrome. And then, apart from that, there is a merging, di ba, in your beta and your gamma region. So this is referred to as your beta-gamma bridging effect. Okay, there is a merging or a bridging effect seen between your beta and your gamma region. Okay, so this is actually caused by of an elevation of the immunoglobulin IgE. Okay, so there is an increase in your IgA. Yes. And this increase, parang it will, anong pangalan nito? Yung overshadow. Okay. It increases so much, so much, that it overshadows already the beta region. Okay. So, kumbaga, this increase in your IgA will now cause the bridging effect or the merging of your beta and your gamma region. So that means, okay, parang nag-overflow na, di ba? Parang nag-overflow na siya to the beta region. Alright? So that's how significantly increased your IgA is in the case of your liver cirrhosis, such that it will now cause a beta-gamma bridging effect. Okay? So inherently, the problem really is in your gamma region. But because of too much IgA, so this will now, yes, this will now create a bridging effect. Yes. Okay, yes, an overflow, kumbaga, to your beta region. All right, so, yes, so that is also, yes, check natin. All right, one significant or distinct electrophoretic pattern that is associated with your cirrhosis. Okay. So now let's move on to the next two diseases. The next two diseases we have your this one. Okay, so we have your alpha-1 antitrypsin deficiency, okay, which is associated with emphysema. Emphysema. Me, I'm much more comfortable with emphysema. So it's up to you as long as you know. All right, so next we have our emphysema. Okay. Ayan. All right, so as you can see, yes, as you can see, the only distinct abnormality in your electrophoretic pattern is that there is a very low concentration of your alpha-1 fraction. Okay, so again, this is because your alpha-1 antitrypsin, this is a predominant alpha-1 plasma protein. Okay, yeah, so such that its deficiency will greatly affect, yes, the region, the alpha-1 region. All right, so yeah, so we have alpha-1 antitrypsin deficiency in the case of your emphysema. Okay, so next we have your by the way, may I just mention? So the deficiency of your alpha-1 antitrypsin in your emphysema. So this is significant. Ay, parang nabanggit ko na. Yeah, I think. But hindi ko pa nabanggit na it's usually your alpha-1 antitrypsin. So it comprises approximately 90%. Okay, of the total alpha-1 plasma protein fraction. So that's why, as you can see, if it is deficient, then it will really greatly affect, talagang really greatly affect the band that is formed in your alpha-1 region. Okay, so the next one, so this one, we have this one naman is your monoclonal gammopathy. Okay, di ba? You encounter your monoclonal gammopathies in your hematology. You encountered them also in your immunology, right? Yes. So when we say monoclonal gammopathy, yes. So this involves, yes, this involves the presence of very high, okay, it involves the presence of a very high um, um, gamma, yes, gamma protein fraction, okay, very high. Yes, and this particular electrophoretic pattern seen in the gamma region, So this has been described to be a spike. Okay, so whenever you see the term spike in the gamma region, so that will automatically refer to your monoclonal gammopathy. Okay, yes. So what are examples of monoclonal gammopathy? Of course, how can we forget our multiple myeloma? Di ba your multiple myeloma, correct me if I'm wrong because I haven't handled hematology for a long time. Um, I think, I think lang, okay. In multiple myeloma, so this is a malignancy that involves your plasma cells in particular, right? Yes, so there is an abnormal proliferation of your plasma cells, right, in your multiple myeloma. Okay? In your multiple myeloma, there is an abnormal proliferation of your plasma cells. And if you're going to look at the clone of plasma cells that is involved, so it's only one. So it involves only one clone of plasma cells that abnormally proliferates. So since the proliferation is abnormal, of course, di ba? The antibody, remember your plasma cells, they are responsible in producing our antibodies. So it's since it is abnormal, then the antibodies that are produced will likewise be abnormal. Okay, so that's why you are much more familiar with the common name of this particular antibody, abnormal antibody. So we have your Benz-Jones protein. So your Benz-Jones protein, that is actually the abnormal monoclonal antibody that is produced in your multiple myeloma. Okay, yes. You know what, guys? They really like multiple myeloma in the boards. Yeah, probably because you're supposed to correlate your knowledge not just in clinical chemistry, but in clinical microscopy, in hematology, as well as in your immunology and serology. Okay, so when you study multiple myeloma, you don't just study for one professional subject. So that's four. Tama ba ako? Yeah, that's four professional subjects, right? Yeah. So please do study your multiple myeloma. Okay. All right. So yeah. So another example of a monoclonal gammopathy is your Waldenstrom's macroglobulinemia. Okay, so actually, in the clinical setting, okay, in the clinical setting, your serum protein electrophoresis is primarily used for monoclonal gammopathy. Okay. Yeah, of course, it can be used for emphysema, it can be used for liver cirrhosis, it can be used for nephrotic syndrome. However, um, in this particular disease states, there are also other tests which are more practical to use for the diagnosis of your patient. Okay, because as you can see, your serum protein electrophoresis is very taxing, di ba? It is very labor intensive because of the different steps. Okay, so ang application niyan talaga, are the primary application of your serum protein electrophoresis is in the diagnosis of your monoclonal gammopathy. You can read it in Bishop. This was mentioned by Bishop, and this has been asked in the board exam. Okay, yeah. SPE is primarily performed for the evaluation of monoclonal gammopathy. Okay, so please do not forget. Alright. Ayan. Ayan, hindi nyo nakikita yung mukha ko, diba? Yes, because our curtain is red and the sunshine is directed towards our window. So I look like a hot dog. I don't want I don't want to open my video. Ang red ko ngayon. Okay, sige. Next na. All right, so the last two we have, this one is Your chronic inflammation. Wait a minute. Chronic inflammation. So both of them are inflammatory conditions. So this one naman is our acute inflammation. Okay, so first let's discuss your chronic inflammation. All right. Okay. So since it's an inflammatory, diba? Since it's an inflammatory condition, so of course, it's expected that our acute phase reactants are increased, diba? Our acute phase reactants are increased. But as you can see, aside from our acute phase reactants that migrate towards your alpha 1, alpha 2, and your beta region, there is also an increase in the gamma region. Okay, remember, this is chronic. So what did we learn when an inflammatory condition is chronic? Your body starts producing antibodies in order to combat also that particular chronic inflammation. Okay? Yes, of course, chronic. Ibig sabihin matagal. 'Di ba? Matagal. Right? What's matagal in English? Um, Matagal is matagal. Wait, matagal is long, 'di ba? The duration is long. That's chronic. Okay? Yeah. So since the duration is long, then the immune system of the body is now able to respond, 'di ba? Is now able to respond by producing your antibodies. So as you can see, yes, it's not just your inflammatory substances that are increased, but also your antibodies. Right? So that's why there is an increase in your alpha 1 region, alpha 2, your beta, as well as your gamma region. All right. And then as you can see, when it comes to the albumin concentration, so it is not decreased as compared to your acute inflammation. Diba? As compared to your acute inflammation. Yes. Of course, the body will start to cope up also with that particular inflammatory response. Ah, so that's why, as you can see, hindi naman the level of your albumin is not decreased. Okay? So in the case of your chronic inflammation, yeah, so since it involves the production of your antibodies, yes, as a normal response of the body to the presence of an inflammation, um, there is an increase in your gamma region. However, it is not a spike, di ba? So if I'm not mistaken, if my memory serves me right, so they would usually refer to this as a diffused, yeah, as a diffused increase in the gamma region. So diffused meaning all areas of your gamma region are actually increased. Okay, it's a diffused increase in the gamma region. So that's your chronic inflammation. So aside from that, your chronic inflammation is otherwise referred to as your polyclonal gammopathy. Okay, so we have polyclonal gammopathy. All right. So in contrast to that of your multiple myeloma, which involves abnormal proliferation of a single clone, of one clone of your plasma cells. In the case of your chronic inflammation, this would involve several clones of your plasma cells. Okay, that's the term polyclonal gammopathy. Okay, so this is also the reason why it's not just a spike, diba? It is diffused increase in the gamma region. So that's your polyclonal gammopathy or your chronic inflammation. Okay, ayan. So another, we also have our acute inflammation. Yes, so as you can see, there is an increase in our acute phase reactants, particularly those which we refer to as your positive acute phase reactants. Okay, so in addition to that, there is a slight decrease in your albumin. Okay, why? Because again, take note that your albumin is a negative acute phase reactant. Okay, so being a negative acute phase reactant, and since this is acute, di ba, when we say acute kasi the progression is fast, right? The progression is fast, it is for a short duration. Okay, so that's why this will now affect the concentration of your albumin being a negative acute phase reactant. Okay, so the other acute phase reactants seen in your alpha 1 and your alpha 2 regions, they are considered to be positive acute phase reactants. Positive because they are increased in the case of your inflammation. Okay? Yes, so those are the different abnormal electrophoretic patterns that you have to master. Yes. Yeah. Okay. So now let's move on to the different methods. Actually, I parang konti lang to. Yeah, dalawa lang. I am yeah, dalawa lang. Okay. I actually, ang dami actually, class. Okay. I just want to present it in this manner. Kasi actually na naman. Okay, sa board exam, paulit-ulit lang yung method. Okay. Paulit-ulit means they asked about this method over and over again. Yeah. All right. So take note that in the laboratory, yes, so most of the methods that we perform in clinical chemistry are performed in order to determine your total protein or your albumin. Okay, ayan. So for your total protein methods, so we have your Keldal method. Yes, your Keldal method, this is based on protein digestion. Yes, and then after which you are going to measure the nitrogen content. So basically, that's your Keldal method. All right. So your Keldal method, this is considered as the reference method for total protein determination. Yes, for your total protein determination, we have your Keldal method. Okay. So in your Keldal method, uh, this is also based on the assumption that the average nitrogen content of proteins is 16%. Okay, is 16%. So that means we are just measuring the nitrogen content of your proteins. Okay, yes. So values are usually underestimated in this case. So in order for us to convert nitrogen content to protein, so we should multiply it. Okay, yes. Kasi nitrogen content lang ang mini-measure natin dyan. Alright? Okay. Yes, yes. Alright. So the formula, the conversion factor that we can use for this one is 6.4. Kasi yan ang lumabas sa board exam. Okay, 6.4. But actually, if you are going to read other references, ayan. So, nitrogen content is, nitrogen content, okay, so this is multiplied by 6.54. Yes, nitrogen content is multiplied by 6.54. Okay, so please take note of your 6.54. But actually, yes, actually na naman. Anong pangalan nito? Other references made use of the conversion factor 6.25. Okay, yes. So in other references, ang ginagamit nila is 6.25. 6.54 is the one that was asked already in the board exam. Okay, but of course you also have to know 6.25. But if you cannot memorize both, then I suggest that you memorize 6.54. Okay, ayan. So another method is your refractometry. Okay, so your refractometry, this is based on the refractive index of solutes present in your serum. So this is a rapid and simple method, and it is based upon the assumption that uh, non-protein solids are present in the same concentration as your calibrating serum. So there is a need for you to make use of your calibrating serum in order to disregard, yes, in order to disregard or remove, 'di ba, the interferences which might be caused by your non-protein solids. Okay, yes. So you make use of a calibrating serum. All right. Next, we have our burette method. Yes. So for our burette method, so this is based upon the amount of peptide bonds present. Yes. So take note that in the case of your burette method, the minimum number of peptide bonds present in your protein in order for it to be measured by your burette methods is 2 peptide bonds. Okay, so minimum of 2 peptide bonds should be present. All right. So in particular, cuprous ions bind with your peptide bonds, producing the positive result, which is a violet color. Okay, ayan. All right. So another, we also have our dye binding technique. Okay, so we also have our dye binding technique. Yes. So for our dye binding technique, wait a minute. So for our dye binding technique, okay, this is based on the ability of your proteins to bind to certain dyes. Ano ba yun? Kaya siya dye binding. Okay, so anyway, we can make use of several dyes in the case of this method. The most commonly used, yes, the most commonly used, all right, so dye binding technique. So the most commonly used, um, most common, yes. Anong pangalan nito? Most common dye that is utilized is your bromcresol green. Okay, however, take note that the most specific, okay, most specific, yes. Take note that the most specific, yes, the most sensitive, talaga, most specific, most sensitive is your bromcresol purple. Okay, most sensitive, most specific, most precise. Among the different dye binding techniques, we have your bromcresol purple. Okay, bromcresol purple. Yan. So this is actually na naman. This is for in the case of your protein as well as your albumin. So we have your most specific, okay, and most sensitive. So we have your bromcresol purple. Okay. Yes. And then they have asked also the dye that is used for your amino acids. We have your ninhydrin. Do not forget. Okay, ninhydrin. All right, and then the last method, we have your turbidimetric method. So this is based upon the precipitation of your proteins. So this is actually the same as that of the precipitation techniques which are utilized in clinical microscopy for our urine samples. So there are 2 reagents that we can use. We have 3% SSA, okay, sulfosalicylic acid. Tama ba? And then we also have your trichloroacetic acid or your TCA. Okay, so those are the reagents that we use for your dye binding techniques. Dye binding techniques. So like for your turbidimetric techniques, I think I forgot to mention something. Yeah, I forgot to mention. So, kasi lumabas na to sa board exam. Right. So take note that for your burette method, yes, there are the reagent that is utilized for your burette method is referred to as your Rochelle's salt. Okay, Rochelle's salt. So this is, yes, this is chemically referred to as your sodium tartrate tetrahydrate. Okay, so I repeat, Rochelle's salt is chemically referred to as your sodium tartrate tetrahydrate. Alright, so this will be allowed to react with your alkaline copper. Yes, alkaline copper and, sige, lagay ko na nga lang, alkaline copper, okay, plus your NaOH, sodium hydroxide, plus your potassium iodide in order to produce your alkaline copper tartrate. Okay, in order to produce your alkaline, um, yes, alkaline copper titrate. Okay, yan. So, this particular, yes, this particular reagent has been asked in the board exam already. Okay, so please do not forget your Rochelle's salts. Okay. All right, we are done with our total protein. So next we have our albumin methods. Yeah, this is the last slide for proteins. So the following are our methods for albumin determination. So we have salt precipitation. Yes. So in your salt precipitation method, there is a need for us to precipitate your globulins because what we are trying to measure here is just your albumin. Okay, so globulins are precipitated and then your albumin remains in the supernatant. So in this case, we will be using the supernatant, diba, that contains your albumin. And then the next step would be measurement of your albumin via your burette reaction. Okay, so again, what's the basis for our burette reaction? So the presence of at least two peptide bonds. Okay? And then we also have the different dye-binding techniques. We can make use of your methyl orange, but it's not specific. Your haba. Ito, lagi nilang tinatanong si haba. Okay, yes. Haba, this is otherwise or chemically referred to as your 2,4-hydroxy, okay, azobenzene, benzoic acid. Okay, so 2,4-hydroxyazobenzene benzoic acid. Okay, so that's your HABA. So that is ang HABA, di ba? Okay, that's your chemical name. So do not forget. So this is also utilized for your dye binding techniques, but take note that in the case of your HABA, the problem with this method is that it has many interferences. Okay, so that means if you are going to use HABA, there is a likelihood that your, yes, your, anong pangalan nito? Your reading might be falsely elevated, diba, or falsely decreased because of the many interferences. Another, we have our BCG. So this is sensitive. However, it usually overestimates low values. Okay, yes. So that's why also in the case of our albumin, we prefer your BCP. Yes, however, BCG is the most commonly used. Yes, but if we are going to consider the best albumin method, it would be dye binding with the use of your bromcresol purple. Okay, so specific, this is sensitive, and it is precise. Of course, the most accurate one is your electrophoresis. However, just like what I have mentioned, um, electrophoresis is very, it is very labor intensive. And it would usually require additional, yes, it would usually require additional equipment in the laboratory. So as for the practicality of performing electrophoresis as your albumin method, or as your method of determining albumin in the laboratory, so it might not be practical. Okay, so that's why we oftentimes employ the use of your dye binding techniques. All right, so we are done with our proteins. So actually, our non-protein nitrogen compounds, it's very short lang. It's a very short discussion. Okay, ayan. Yes, so non-protein nitrogen compounds, so these are substances in the circulation that contains or that contain nitrogen. However, we cannot classify them as proteins because remember, di ba, our proteins, they have to have carbon, they have to have hydrogen, they have to have oxygen, and then of course nitrogen, which separates them or makes them distinct from the other biomolecules. Okay, so in the circulation, so we have our NPNs. They contain nitrogen, but they are not proteins. Okay, so basically, what are the different NPNs that we have? So we have your urea, amino acids, your uric acid, and then we also have our creatine, and our ammonia. Okay, ayan. So in the case of our NPN, so the basic knowledge knowledge that we have to be able to establish is, of course, ang importante sa kanya. Wow, paulit-ulit, ma'am. Yes, oh, ito na. Okay. So the important thing that you have to remember in the case of our NPNs is that is how rather they are metabolized. Okay, how they are metabolized or how they are produced inside the body. Okay, so their synthesis po. Yes, their synthesis, okay, is very important. Okay, so first we consider urea. So natin, take note that in the case of urea, urea is considered to be the end product of protein metabolism. Tama? It is the end product of protein metabolism. Another is our uric acid. Uric acid is considered to be the end product of urine metabolism. Okay, creatinine, kasi mahilig sila sa term na end product. It is the end product of muscle metabolism. Okay, so please take note of that. All right, so urea, end product of protein metabolism, uric acid, end product of urine metabolism, creatinine, end product of, muscle metabolism. Okay, so aside from that, so out of all the NPNs that we have, okay, for our NPNs are either used to, yes, most rather of our NPNs are used to assess renal function. Okay, so in particular, your urea, okay, what else? Your uric acid also, as well as your creatinine. Okay, so these are the three most commonly used NPNs for the assessment of your renal function. Okay, so usually silang tatlo ang ginagamit natin in the laboratory. Okay, yes. However, if for example, you are to choose two only, diba? Two NPNs only that are commonly utilized for renal function, the correct answer would be urea and creatinine. Okay, if it's three, then we have urea, uric acid, and creatinine. If it's two, urea and creatinine only. Right? So aside from that, another important NPN that is utilized naman for the assessment of liver function is your ammonia. Okay, so particularly what function of the liver is assessed? Are we trying to assess if we measure your ammonia levels. So we have detoxifying, diba? It is the detoxifying function of your liver. Okay, synthetic function, we have your total proteins, particularly your albumin. Detoxifying function, we have your ammonia. Okay, we have your ammonia. All right, so those are the things that you have to remember. What else? So take note also of the term azotemia and your uremia. Okay, so uremia, so this involves an increase in your urea with renal failure. Okay, azotemia on the other hand, so this involves an increase in your urea level in blood. So actually, some references would say that azotemia does not only involve your urea. Oh, yes. Yeah, that may be true. However, take note that urea kasi, this is the predominant. Okay, this is the predominant NPN compound. And so, if there is a type of NPN that would usually be increased in the case of your azotemia, it would be your urea. Okay, ayan. So, may I just erase? So, azotemia, so this can be divided into three types. So, we have pre-renal, okay, renal, and then of course, post-renal. Okay, so when we say pre-renal azotemia, so um, the problem, okay, the problem or the defect uh, lies in the blood, diba? The blood that is perfused or delivered to your kidneys. So that means the defect is before your kidneys. There's nothing wrong with your renal function. Okay, there is nothing wrong with your renal function. The problem is that, okay, the problem is that urea or uh, yes, urea and any other NPN, together with any other NPN or urea alone, ayan po, there is already an increase in their concentration prior to your kidneys. Okay, yes. So this is po a type of azotemia that involves an increase in the concentration of the blood that is perfused, 'di ba? Perfusion or blood to your kidneys. Okay? Yes. So there's something wrong with the delivery of blood. Yes, thereby allowing the increase of your NPN, or there is already something wrong with the blood. The blood is already increased, or the blood is already increased. The NPN in your blood is already increased. Okay, so if there's something wrong with perfusion, ano ang perfusion class? This is how efficient blood is being delivered to your kidneys. 'Di ba, we learned that in your clinical microscopy that blood flow to your kidneys will affect its function. Okay, so say for example, if there is a decrease in the blood flow to your kidneys, 'di ba? If there is a decrease in the blood flow to your kidneys, what will happen? Of course, your NPN, okay, your urea will be increased. Tama? Because blood is not efficiently being delivered or being perfused to your kidneys. So that's why your kidneys cannot efficiently remove, di ba? The right amount of NPN in your circulation for excretion. Okay? So there's something wrong with perfusion. Alright? Or, katulad nga ng nakalagay dito, blood to the kidneys. There is already an increase in the NPN in your blood prior to its delivery to the kidneys. Right? So of course, yes, your kidneys, yeah, true. Biglang, yeah, true. Your kidneys is supposed to remove your NPN, but remember, there is a maximum threshold, right? There is a maximum level at which your renal tubular cells are capable of removing your substances from the circulation. Okay? And so, if this maximum level is already reached by your renal tubular cells, then it will no longer be able to remove all of the excess NPN compounds in your circulation. Okay, so those are, in general, the causes of pre-renal azotemia. Okay, perfusion, mabagal. The flow of blood to your kidneys is not efficient. It is slow. Okay, or your blood already contains a lot of NPN, such that your kidneys are not able to remove all of them or remove, yeah, the excess. Okay, ayan. All right, so examples of conditions that will result to pre-renal azotemia. So we have congestive heart failure. Diba? When we say congestive or heart failure, your heart is not able to pump blood efficiently. Okay, what else? Shock. Okay, shock. This usually happens, or this can happen in the case of septicemia, 'di ba? If there is infection in blood, okay, so this will lead to low blood pressure. So low blood pressure, lower rate of delivery of blood to the kidneys also. Okay, what else? Hemorrhage also. Diba? In hemorrhage, there is also low BP, right? Low blood pressure. So low blood pressure means low blood flow. Okay, what else? Dehydration, diba? Dehydration. Dehydration. Ulit-ulit ba? Dehydration. So low blood volume, low blood pressure also. Okay, what else? Decrease in blood volume, so on and so forth. Hypovolemia. Okay, so those are pre-renal conditions rather that will result to pre-renal. Okay, and so renal naman, there is something wrong with your kidneys. Okay, defect lies in the kidneys. So that means your kidneys, they are not capable of removing the excess NPN compounds present in your circulation. So that's why it will accumulate in your body. Post-renal, again, there is nothing wrong with your kidneys here, but the problem is there is an obstruction in the flow of your urine. Okay, so take note that if there is an obstruction in the passageway of urine, so the NPNs, which are already there, might overflow into your circulation again. Okay, thereby increasing their concentration. All right. Uremia is different from azotemia because when we say uremia, this is an example of a renal azotemia in which there is an increase in urea with renal failure. Okay, yes. So, yeah, the defect lies in your kidneys. Diba? In the presence of your renal failure, your kidneys will not be able to function properly. Thus, it will not be able to remove substances efficiently from the circulation. And that would include your non-protein nitrogen. Okay. All right, so let's proceed to the next. So we will be discussing NPNs one by one. So first, urea. So I think I have discussed azotemia and uremia already. Okay, so take note that your urea is synthesized in the liver. Okay, yes, from the reaction of your carbon dioxide and ammonia. So it is a major excretory product of protein metabolism. Okay, yes, all right. And then, class, ito tinanong yata ito ng board exam. So take note of your normal BUN to creatinine ratio. Okay, so the normal BUN to creatinine ratio is 10 to 20 is to 1. Okay, so the normal BUN to creatinine ratio is 10 to 20 is to 1. Okay, so of course I discussed this already, the conversion of your BUN to urea. Okay, so what are the different methods involved in the assay of your urea? So they can be divided, or yeah, they can be divided into several types. We have your enzymatic methods, we have your chemical methods. Okay, so first we have your enzymatic methods. So enzymatic methods would usually involve the formation of your ammonia. Yes. Okay. Your enzymatic methods has a greater specificity, however, they are more expensive as compared to our chemical methods. Right? Yan. So, the coupling enzyme that is utilized for our enzymatic method is your L-glutamate. Diba? GL, that's glutamate dehydrogenase. Okay, glutamate dehydrogenase. All right. So this will now measure the rate of disappearance of your reduced NAD. Okay, reduced NAD. Okay, disappearance of reduced NAD. All right. So another, we can also make use of an indicator dye in this case. Yes, indicator dye will measure the color change of your pH. Yes, pH indicator. And then we also have our Berthelot reaction. Yes, and ang tinatanong, this involves this particular reaction. So we have ammonia. Yes, ammonia, and then we have the we have sorry, we have anong pangalan nito? The production of your endophenol. Okay, yan. So class, yes, itong mga these enzymatic methods, ang tinanong na before is what methods daw are incorporated in our automated machines. Okay, so please take note that there are usually two methods that are incorporated in our automated machines. We have the glutamate dehydrogenase, yes, and the use of your indicator dye. Okay, but between the two, uh, a better answer would be the coupled reaction. Okay, yes, the coupled reaction that makes use of your glutamate dehydrogenase. Right. So before, laging tinatanong din ang Berthelot, but parang nowadays hindi ko siya masyadong anong pangalan nito? Hindi ko siya masyadong naririnig, your Berthelot reaction. Okay, yes. All right. So those are the different enzymatic methods. And so now let's proceed to your chemical methods. So for your chemical methods, we only have two: the use of your diacetylmonoxime and the use of your orthotaldehyde. Okay, yes, orthotaldehyde and your diacetyl monoxime. Okay, so in your diacetyl monoxime, this is a colorimetric method. It is simple, it is not expensive, however, it's not specific also. Okay, yes, it's not specific. And the end result is the production of your diazine substance, which has a yellow color. Okay, so for your orthotaldehyde method, so this involves the production of your isoinulin, and this particular substance will again react in a next reaction, which will involve your um, wi- wi- which will now involve the production, of a colored product. Okay, yan. So bypassing lang itong mga methods natin, ha. Yes, because in the recent board exams, what they are asking are actually the basic. Okay, yes. Parang hindi masyado sa mga methods. Yes, unlike during my time, they ask a lot about methods. Yeah. However, nowadays in CC, it's more on the concepts. Okay, like for example, what is the predominant NPN? Ganun lang siya. Urea. O, di ba? Urea is the predominant NPN. Okay? NPN that is not used for renal function assessment. So we have ammonia. Okay, so on and so forth. So basic things about your NPN. Okay, not so much when it comes to the method. All right. So next NPN, we have our creatinine. Okay, so I will just be discussing about creatinine kasi this is the one naman that is clinically significant in our in our subject, clinical chemistry. Okay, so the production of creatinine, 'di ba, in your muscle cells. Yes, in your muscle cells kasi there is a need for us to have a mechanism by which we can store energy. Okay, and that mechanism involves the conversion of amino acids to creatine. Okay, yes. So what amino acids are involved in the production of creatine? We have arginine, glycine, and your methionine. So your creatine, how is it able to store energy? Your creatine will be phosphorylated. Tama? It will be phosphorylated with the use of your creatinine kinase. So that means a phosphate group will be transported to your creatine so that it will become phosphocreatine or creatine phosphate. Okay, always take note that phosphorylation reactions, they are important po in order for the cell, okay, in order for the cell to have stored energy. Ma'am, bakit paano naging stored energy? This is because, remember, if you are going to produce chemical energy inside the body is in the form of adenosine triphosphate. Tama? Adenosine triphosphate. So that means if you conserve phosphate group, then you can conserve energy. Okay? And that is the purpose of your creatine phosphate or your phosphocreatine or your phosphocreatine in your muscle cells so that you would have available phosphate in the production of your ATP. Okay, if you're going to look at the different mechanisms by which cells produce ATP, it would always be or it would always involve, 'di ba? Transferring a phosphate group from a certain substance to your ADP, your adenosine biphosphate, so that it becomes ATP, adenosine triphosphate. Okay? Yes, kasi baka mamaya ang iniisip ng iba, ha? Energy? Energy, ano? Energy? Yeah, ano sinabi ko kanina? Energy storage. 'Di ba? The energy that cells need is just glucose? No. Okay, no, it's not just glucose. Even if you have a lot of glucose in your body, if you don't have phosphate groups, how are you going to form ATP? 'Di ba nga? Okay? All right? So that's why creatine phosphate or phosphocreatine, it is an important substance for us to store energy in our muscle cells. Okay, so remember our muscle cells, they are constantly working, they are constantly undergoing metabolism, contraction, relaxation, so on and so forth. So that's why they need a lot of energy. Okay. Yeah. So if you are going to metabolize phosphocreatine in your muscle cells, so this will now form your creatinine. Okay, yes. So that means end product of muscle metabolism is your creatinine. Okay, yes. So in the assay of your creatinine, yeah, so of course, who can forget your Duffy reaction? Okay, so take note that your Duffy reaction, so this is otherwise referred to as your alkaline, diba? Alkaline picrate, okay, alkaline picrate method. All right, so your alkaline picrate method, this is considered to be a simple, however, it's a non-specific, yes, it's a non-specific colorimetric method. Okay, yes, non-specific colorimetric method because Yeah, because there are a lot of interferences which might be present in our sample, in this case serum, that will interfere with the determination of your creatinine. Okay? Yes. So what is pangalan nito? What is the reaction that's involved? We have creatinine plus your picric acid. So it will form a red-orange chromogen. Okay. Yes. Since there are certain interfering substances that might be present in our sample, so sometimes there is a need for us to perform your adsorbent technique. Yes, particularly before when they were still making use of your protein-free filtrate. Diba? But now we don't make use of your protein-free filtrate. However, since our board of examiners still value the methods even if they are already considered obsolete, so it's important for us to know also, diba, the absorbent technique that they use to perform uh, in the case of your creatinine determination. Okay, so yan. So there are two reagents that we can use. We have your Fuller's Earth. Okay, Fuller's Earth. So your Fuller's Earth, this is your aluminum, okay, aluminum magnesium silicate. Okay, so I repeat, your Fuller's Earth is your aluminum magnesium silicate. And then the other one is your Lloyd's reagent. So this one naman is your sodium aluminum silicate. Okay, so both your Fuller's Earth and your Lloyd's reagent are used as adsorbents, okay, as adsorbent reagents or substances in your Jaffe reaction. Okay, yan. So another, we also have your kinetic Jaffe. The original Jaffe reaction is based on endpoint. Yes, it's a colorimetric or endpoint colorimetric procedure in which the pangalan nito, the concentration or the absorbance of your creatinine or the chromogen rather that is produced in the reaction is measured once only. Okay, so one absorbance reading only. Okay, so that's your endpoint Jaffe. However, there is already a new reaction. So this is also the type of Jaffe that we use in the laboratory. So we have kinetic Jaffe. Or for those who have been or who had the chance to perform semi-automated processing using our StatFax, di ba? As you can see, how many absorbances did you read or did you take for your creatinine determination? We have two absorbances. And that is basically what is involved in your kinetic Jaffe. Okay, so what we are measuring is the rate of change. So that means it would involve two or even more readings. Okay, so in your kinetic Jaffe, two readings, diba? Two absorbance readings. Yes, yes, because we are after the rate of change. Okay? All right. Same rin lang naman. So serum plus alkaline peak rate. The only difference is that the number of absorbances or the number of measurements that you do. Okay? Ayan. So in addition to your Jaffe reaction, we can also make use of um, another reagent, another colorimetric method, which involves the use of 2,5-dinitrobenzoic acid. Okay, so this one is allowed to react with your creatinine, and the end product is purple. Okay, so the color of the product that is formed is purple. All right. By the way, for your creatinine, there is no reference method yet. However, they are proposing that we make use of your HPLC, your high performance liquid chromatography, as a reference method for creatinine determination. Okay? So next, we move on to second to last, we have your uric acid. Okay, ano ba ang masasabi ko sa uric acid? Wala, charot. Hindi. All right, uric acid. So, the popular colorimetric method that is utilized for its determination is your Caraway. Diba? Tama ba ako? Caraway. Yes, Caraway method. The problem with your Caraway method is that um, turbidity. There are problems encountered with turbidity, as well as as well as several common drug interferences. Okay, so there are several common drug interferences. Okay, ayan. All right. So in your Caraway method, so ito siya. So your Caraway method involves the use of your phosphotungstic acid. So this will be allowed to react with your uric acid, producing now allantoin plus your tungsten blue. Okay, plus your tungsten blue. So this particular tungsten blue is the positive result, and it can be measured spectrophotometrically. Okay, it can be measured spectrophotometrically. All right, so there is also an enzymatic method that we can use. Okay, so uric acid is converted to allantoin, carbon dioxide, as well as hydrogen peroxide by the enzyme uricase. Okay, by the enzyme uricase. Ayan. And this is measured spectrophotometrically at 293 nanometers. Yes. So, your enzymatic method, especially if you are going to make use of your enzymatic hydrogen peroxide method, so it would usually involve a coupled reaction in which your hydrogen peroxide will be acted upon by the coupling enzyme, catalase or peroxidase. Okay, so again, so since it involves converting your hydrogen peroxide, so interferences may be observed in the presence of your reducing substances. Okay, ayan. Alright. Actually, ang tinatanong sa uric acid, aside from its metabolism, diba, and product of purine metabolism, okay, is its clinical significance. So usually, tinatanong po ang clinical significance ng ating uric acid. Okay, so take note class ha, kasi lagi na itong tinatanong before. Take note that your uric acid, saan siya galing? It comes from your purine. What is the significance of your purine? Take note, purine is a nitrogenous base. Diba? It's a group of nitrogenous bases present where? In our nucleic acids. Okay, so that means uric acid may only be produced if there is, or if there is a high amount of nucleic acids in the body. Okay, normally may uric acid ba tayo? Yes, because our cells have a normal lifespan. Diba? They have normal lifespan. And after this particular lifespan, so of course they will undergo programmed cell death, right? They will undergo programmed cell death, thereby liberating nucleic acids. And of course, if you have nucleic acids, then you have a source of purine, then this purine will be converted to uric acids. Uric acids, ang dami. Uric acid. Okay, so saan siya galing? They are from your cells. Okay, yeah. So if there is an increase in cell turnover, okay, so meaning a lot of cells normally undergo, di ba? Hindi siya normal if the cell turnover is increased. So increase in cell turnover, okay, so this will also increase your uric acid. Tama, yes. So that's why if you're going to look at the clinical significance of uric acid, it is increased in conditions with high cell turnover. Okay, yes, so high cell turnover. And yes, they usually ask about chemotherapy. Okay, patients undergoing chemotherapy have increase in cell turnover because diba, in chemotherapy, um, you have medications, diba, that are directed towards your abnormal cells. So they will kill your abnormal cells. So in addition to your abnormal cells, your normal cells will likewise be killed. Okay, thereby increasing your cell turnover. So meaning death. Sige, lagay natin ha. Death of cells. So if there is an increase in the death of cells, so this will also provide more nucleic acids, more purines, more uric acid. So that's why in patients who are undergoing chemotherapy, their blood uric acid is increased. Okay, ayan. So another, actually this is naman in your clinical microscopy. So uric acid is likewise increased in your Lesch-Nyhan syndrome. Diba? It is likewise increased in your Lesch-Nyhan syndrome. Okay. So ang tinatanong nila in clinical chemistry when it comes to your Lesch-Nyhan syndrome is what enzyme is deficient? Okay, increased also uric acid. Wait lang. So what enzyme is deficient in your Lesch-Nyhan syndrome? So we have hypoxanthine, guanine, ribosyl transferase. Okay, so hypoxanthine, guanine, phosphoribosyl transferase. So that is HGPRT. Sorry, HGPRT. Okay, so that is the enzyme that is deficient. Right? So we move on to the last slide. Wow, 2 hours ko nag-discuss. Ammonia. Okay. Alam mo ang tinatanong sa anomia? Anomia tuloy. Ammonia. You know what they asked about an ammonia? It's the collection procedure. Okay, yes. Oh my gosh, guys. Okay, so take note that when it comes to ammonia, okay, when it comes to ammonia, ayan, sorry, when it comes to ammonia, you can either make use of venous blood or arterial blood. One thing is for sure, parang may ganun na kanta. Okay, freshly drawn, diba? The sample should be freshly drawn. Okay? Freshly drawn sample. Why? So this is in order to prevent false increase. Okay? Why false increase? Because if you allow your sample to stand even for 1 hour or even actually for 30 minutes without, without following proper storage. So concentration of ammonia rises rapidly due to in vitro deamination of your amino acids. Okay, yeah. So take note that your ammonia, it is actually parang it's ano pangalan nito? It's an intermediate product in the complete metabolism of your protein. So of course, after you have converted your proteins into amino acids, the next thing that you have to do is to deaminate your amino acids. So in the deamination of your amino acids, you would be able to produce your ammonia. Okay? Yes. So in vitro deamination, takes place. Yes, and that's the problem if your sample for ammonia is not freshly drawn. Okay, so magkakaroon ng in vitro deamination, thereby resulting to a false increase in your ammonia. Okay, so when it comes to the type of sample, you can make use of of venous blood, and the preferred anticoagulant is EDTA. Okay, so take note that if you are going to make use of venous blood, blood should be obtained without, okay, blood should be obtained without trauma. Okay, and then again, the anticoagulant that is used is EDTA. Okay, so you can also make use of your arterial blood. Arterial blood, so the the anticoagulant that is to be used is your heparin. Okay, guys, they love heparin in the board exam. Okay, so in 2021, heparin was asked in vitro, in vivo clotting. So anticoagulant that prevents in vitro and in vivo clotting, that's heparin. Anticoagulant that is used for arterial blood, it was asked last January. So again, heparin. In HEMA, okay, what anticoagulant will result to a bluish background? Heparin. Okay, yeah, they like heparin. So that's why if you don't know the answer, just answer heparin. Okay, but of course, if only you don't know the answer, ano? Okay, because they like heparin. All right, so take note. Dami ito take note. That ano pala nito? Take note that the sample should be placed on ice immediately. Okay, it should be placed on ice immediately. Okay, and when it comes to the preparation of your specimen, it should be centrifuged. Okay, it should be centrifuged at 0 to 4 degrees Celsius within, okay, within 20 minutes. Uh, how tuloy? When are you supposed to perform the assay or the test? It should be assayed as soon as possible. Right? So yan. So after performing the assay, so what is the recommended storage for your sorry, sample? So storage of your sample, it should be frozen at negative 20 degrees Celsius. So at this particular temperature, ammonia is stable for several days. Okay? Ayan. Another pa pala. So in the case of your ammonia, yes, in the case of your ammonia, hemolysis should be sorry. Hemolysis should be avoided. Why? Because RBCs contain 2 to 3 times as much ammonia as your plasma. Okay? Ayan. Okay, so in the case of the clinical significance, in the case of the clinical significance of your ammonia, yes, of your ammonia is it being an analyte that we can test in order to, yes, in order to determine the detoxifying capacity of your liver. Okay, the problem is your ammonia is toxic. Yes, ammonia po is toxic. Yes. So that's why you have to process it to a less toxic substance. And again, what organ is responsible for that? It's your liver. Yes, it's your liver. Ayan. So in the liver, your ammonia is consumed by your parenchymal cells or your hepatocytes in order to produce urea. So any damage or dysfunction of the liver, okay, any damage or dysfunction of the liver, this will result to an increase in your blood ammonia concentration. Okay, yes, this will result to an increase in your blood ammonia concentration. All right, so therefore, what is our answer? NPN, that is not dependent on renal function. Diba? NPN that is not dependent on renal function. The answer is ammonia. Okay, so another problem with your ammonia is that high concentrations are neurotoxic. So that's why it can result to encephalopathy. Encephalopathy. Okay? Tama? Ayan. Um, yes. Ayan po. Alright. So yes. So it is neurotoxic and it can affect the brain, leading to encephalopathy. Encephalopathy ang nakalagay sa akin. Encephalopathy. Alright. So yan. Encephalopathy. Tama. Yes. Other terms that they usually, yes, aside from encephalopathy. Ano ba? Encephalo. Ano ba? Encephalopathy. Okay, so another other terms that are utilized to refer to the clinical significance of your ammonia. Yes, we have hepatic coma. Yeah, hepatic coma. So actually, hepatic coma, this is otherwise referred to as your hepatic encephalopathy. Okay, another is your Rice syndrome. Okay. Ayan. So your Rice syndrome, it's not just encephalopathy. Yes, or yeah, it affects actually, sorry, in Rice syndrome rather, if I'm not mistaken, this is an example of a hepatic encephalopathy. Yes, okay. Rice syndrome affects your liver and your brain. Okay. So you just have to be careful when it comes to the analyte that is used for the diagnosis of your Rice syndrome. Why? Because if, for example, the question is asking about blood, if you are to assay blood, okay, what analyte is used in order to diagnose your Rice syndrome? We have your ammonia. Okay, the assay of your ammonia will help in the diagnosis of your Rice syndrome if the sample is blood. However, if your sample is CSF, okay, so take note that it's not ammonia that you're going to determine. It is your glutamate. Diba? Ayan. So you have to be careful Blood, yeah, of course, it's ammonia. However, if we are talking about your CSF, then it is your glutamate. Okay? Ayan. So those are the important things that you have to remember. Actually, for your NPN, in the previous board exams, they are going basic. They are going basic. Yes. Yeah, nagbe-basic sila. So please do not forget to read. Do not skip the introductory portion or introduction of the different chapters of your references because they get from those or from that portion, yung introduction. Yeah. Like for example, in your lipids and dyslipidemia in your Henry's. Okay, major, minor, and abnormal lipoproteins are discussed in the introduction. Okay, the different metabolic pathways for your glucose, it is discussed in the introduction. Yes, anong pangalan nito? The basic things about your NPN introduction still. Okay, so please do not skip the introduction. Okay. All right, so that's all for this video. You have to review for this video. You have to review your serum electrophoresis. Yun lang? No. Yeah, serum electrophoresis, okay, for your proteins. And then for your NPNs, clinical significance, and then the first slide, the things that I discussed in the first. Okay, of course, don't forget ammonia. Okay. All right. So I'll see you again. Bye. I'll see you. No, you did not see me. So yeah. Bye.